Recording in progress.
What do you have to find the equation of a line? A point and a slope. Do we have those? We have the point, which is -3, 1. Do we have the slope? Well, let's see what it says. It's perpendicular to this line. What do we know about perpendicular lines? They're complete, exactly, that's what I said. They're complete opposites. So what's the slope of this line? Well, we have to solve for y. So we have to add x to both sides. Because it has to be in this form in order to find the slope. So we have to solve for y first. Good morning. Then we divide each term by 4. Well, hold on. This equation here, this part here, whenever you have x over a number, that's the same thing. What's the coefficient in front of x? That's the same thing as saying this. Or if I had 2x over 3, that's the same thing as saying 2/3 x. So our slope of this equation is 1/4. That's this slope. What's the perpendicular slope? The slope only. Slope is simply a number. You have to flip the slope. Since the slope is already positive 1/4, the perpendicular has to have opposite signs and flip them. So the slope is -4. So we have our slope is -4. We have our point is -3, 1. What do you have to do now? You could, or you just, all we're missing is the b. We could do the shortcut method. Plug everything in. What's y? What's m? -4. M is -4. X is -3. You have to solve for b. Because remember, what we need to have for this equation, we need to define a slope and a y-intercept. We already have the slope. Negative times negative is positive. 4 times 3 is 12. Get the b by itself, subtract 12 from both sides. Answer is going to be negative. 12 minus 1 is 11. So b is, we know m is -4. B is -11. Plug and play. There's the equation of a line perpendicular to that. Again, all the steps were written down last week on on your notes. It just takes practice. I know, trust me, and I know how difficult it is to do your homework. Trust me, I know. But these are the steps. Once you know the slope, you have a point, just plug it in there, find b, and there you have it. Okay. Now, here's the next question I want to ask you. Are these two lines parallel, perpendicular, or neither? And you can't just guess. You have to tell me why you think it is what it is. When you start an answer with I'm not feeling warm and fuzzy. Okay. So what determines if two lines are parallel or perpendicular? What would be opposite? Not just numbers. The slopes. The slopes. Look at back in your notes, because last week I showed you all that there are four possibilities. If they're parallel, perpendicular, the same lines, or anything else. Good morning. So if they're parallel, the slopes have to be equal. If they're perpendicular, the slopes have to have opposite signs. One's positive, the other one's negative, and they have to be reciprocals of each other. So the only way that you can determine whether it's parallel or perpendicular is to look at their slopes. And in order to look at those slopes, what form do they have to be in? Slope-intercept form. Y equals mx plus b. The equations have to be in this form because whatever's in front of the x will tell you if the lines are parallel or perpendicular. So in this first equation, I have to divide each term by 3. It gives me y equals 6 divided by 3 is 2. That's line 1. The second one, I have to divide each one by 2. Y equals 3 over 2 minus x over 2. So what do you think? You don't need that. You're not adding them together. You can't, because they're not the same type of equations.
So why do you divide by?
Because I need to have it in this form. Has to be equal to y. I divided by the coefficients, so I have y. I have to get rid of this number here. But I need to have y by itself. So whatever you do to one side, you have to do to the other side, to each term. So what y'all's guess? Are they parallel, perpendicular, or neither? Remember, if it's parallel, are the slopes the same?
No, they're not the same.
Okay, what's the slope of line 1?
Why is it 2 base? Fine.
The slope. What's the slope?
-2 over 3?
2. The slope is in front of the x. Not, not the x, just the number in front. What's the slope of line 2? Because there's the x. Remember that the negatives there, I can now take the 1 over 2 x. So there's your slope. So what do we notice about these two slopes? They're opposites. They have different signs. Are they flips of each other? 2 over 1, 1 over 2. They're perpendicular.
Oh, okay.
Yes, you've at first like, are the signs different? Yes. And then are they just flips of each other? So that's what you have to be careful about when you do these things. The second one is being tricky because they put the x back here. So for the slope is whatever number is in front of the X. That's why I showed you this thing here. If you have something like this, you can separate them. So this is your slope. The slope does not have an X in it. It's just a number. It's a rise over run. Make sense? I need you guys to start looking at your homework assignments. Please, 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 please. Because these kind of questions need to start coming out. Let me see. Another example. Find the equation of the line parallel to the line x equals 4 going through -5, 5. Actually, this is the good part about you being here, because I'm asking you questions here that very well could be on tests or homework assignments. These are thinking questions. Find the equation of the line x equals 4 going through -5, 5. It's gotta be parallel. Remember, do we have a point?
Yeah.
Do we have a slope?
No. We don't.
No, we have a slope. It's just not 4.
We have to find it, don't we? No.
What did you say?
I said we have to find it, don't we?
Yeah. Oh, yeah, yeah, that would help. How soon they forget.
It's undefined.
What is?
Slope.
Very good. Because this one here, if it's a line going through x equals 4, it's a vertical line. There's no y values. So the slope here is undefined. So a parallel line going through -5, 5 has to have the same type of equation. So what's that equation going to look like? This equation goes through the x-axis at 4. This one goes through the x-axis at -5. So what's that equation? There's your answer.
That's the answer.
Because if the slope is undefined, it's a vertical line. The only equation you have is it crosses the x-axis. That's the only thing you can find. Find the equation of the line perpendicular to the line that is parallel to the x-axis going through 5, 5. See the point there. Find the equation of the line perpendicular to the line that is parallel to the x-axis going through the 0.55. So now I'm gonna start bringing candy and having y'all pair up in tables. And whatever table gets it right gets candy. Everybody else can watch them eat it. Kit Kats. I love Kit Kats. And if nobody gets it right, I get to eat it. The bag. Anybody have an idea? Well, let's draw your picture. What do you know so far about the picture? So it has to go through, that's the line, has to go through that 5, 5. It's parallel, or it's perpendicular to the line parallel to the x-axis. It's perpendicular to the line parallel to the x-axis.
So what?
Read the first two lines.
What would be right across to the x-axis? So would it be on the negative side?
Do we know the slope already? Yes, we do. The equation of the line perpendicular to the line parallel to the x-axis. What's that line gonna look like? What's the line parallel to the x-axis gonna look like? If it's parallel to the x-axis, it's a horizontal line. What's the slope of this line?
0.
0. Now, it's got to be perpendicular to it, going through that point. So it has to go through that point. It has to be perpendicular. So what's my equation?
Y equals 5.
Because this is our line we're looking for. It's got to be perpendicular to the line parallel to the x-axis.
I thought it was X undefined. No.
It is. But this first part says, I'm looking for the equation of the line that's perpendicular. To what? To the line that's parallel to the x-axis. What does the line parallel to the x-axis look like? Well, it has 0 slope. If it's parallel to the x-axis, it's a horizontal line. That's that one. So we know this one, we know the slope is 0 because the x-axis slope is 0. It's a horizontal line. It's got to be perpendicular to it. Perpendicular to slope 0. If the slope is 0 over 1, what's perpendicular to it? 1 over 0, which is undefined. You have to flip the slope. So it's got to be undefined. Undefined slopes are vertical lines. They're vertical lines going through 0.55. So since it only crosses the x-axis, that's the only point that we have. You have to look at what each part's saying, understanding what the slope, what it means when it says parallel and perpendicular. If it's parallel to the x-axis, if it's perpendicular to the x-axis. So draw your lines, draw your graph. If it's parallel to the x-axis, it has to have the same slope. Horizontal lines have slope 0. So perpendicular lines have to have slope undefined. It's not that difficult, but you have to understand the words. The terms, the definitions of the words are very important. For some reason, parallel and perpendicular always give students the most trouble. I don't know why, but once you understand it, I mean, it'll smack you like a Mack truck. Because it'll say, listen, it's just not, I understand it. It's perpendicular to the line parallel to the x-axis. So it's work backwards. Where's the x-axis? That's horizontal. It's parallel to it, so it's also going to be horizontal. We have to know the slope of horizontal lines. That's 0. So we're looking for the line that's perpendicular to it. Start from the inside piece of information, work your way out. And then perpendicular and parallel lines usually only have either x equals or y equals. I realize this is shaking out the cobwebs from the weekend.
But why is it X, not Y?
Because remember, this is perpendicular. It's perpendicular to the x-axis. Means it goes up and down. It can't have a y because it never touches the y-axis. A line can only have an x and y in it if it crosses both the x and y axis. If it only has a y-axis, then that's the equation of the line. If it only has an x value, that's the equation of the line. Anything else that has a slope will have an equation like this. Anything else. Make sense? Well, it does until you walk out that door. And then you'll forget it all. Yeah, which is why I need you guys to start doing the homework assignments so you see what's up there. Okay, today we're going to look at inequalities and absolute values and their graphs. Inequalities. Inequalities, simply put, state the relationship it states the relationship of points on a number line. So a number line goes from negative infinity to positive infinity horizontally, and vertically the same thing. Down is negative infinity, up is positive infinity. Let's look at the numbers 1 and 3. What can you tell me about the numbers 1 and 3? They're both positive. About 1 and 3 themselves, comparing each other in relationship. Yeah, but it doesn't tell us anything else about them. Can anybody else tell me anything else about them? They are both odd numbers. They're both positive. How about the size of them?
3 greater than 1.
Ah, we know that 1 is less than 3, or 3 is greater than 1. Both of those are true statements. We're going to look at these symbols here. They always point to the smaller number. Inequalities always point to the smaller number. So this one, because we read left to right, this number is less than. So 1 is less than 3. It always points to the smaller. Or we could say that 3 is greater than 1. What it's really telling us is any number to the right of another number is greater than that first number. Any number to the right is greater, any number to the left is less than. Now, how many different rules are there with inequalities? There's less than equal to, greater than equal to.
Oh, there's an equal. Oh,
Okay, then there's an equal to. Then since there's an equal to, there has to be a not equal to. When we put them on a graph, we either have open or closed circles. If it's open, if it's an open circle, that means it's not included. If it's a solid dot, then it is included. And we also could use parentheses and brackets. If they're parentheses, that means they're not included. If they're brackets, that means they are included. You see what I'm saying? Is now it's expanding pretty quick of how many rules there are and how they look. You have set notation, interval notation, graphic notation. That's today's discussion. One, 2, 3, 4, 5, 6, 7, 8. Can you see that, please? This is your test. This is what we're gonna do today. We're gonna film this chart here. These are all the inequalities and how to represent them, what they mean and how to represent them. Go to inequality chart. Graphs are always the easiest to interpret. Now, a solid dot, that means the number is included. What if I'm shading this region, it's going to go from A all the way to positive infinity. So let's say A is 4. What this is saying is starting at 4, give me all the numbers from 4 to infinity. That's what that's saying. Now, how do we use it? Using set notation. Set notation uses inequality symbols. What this thing says is X, because what we're looking at here is the x-axis. I'm looking for all x's greater than A. So X is greater than or equal to, because I can include it. A. In other words, what this tells me is start with A, including A, and go to infinity. X is greater than. Notice how where the arrow is pointing also? It's pointing to the right. That's where the shading is going. Now, how would I do this using interval notations? Interval notation uses parentheses and brackets. Can I include A in my list? Yeah. So I start with A and go on to where? Infinity. I can include A. Can I include infinity? Can you ever get to infinity?
No.
No. So infinity is always a parenthesis. Like this way. So I'm starting at A. This time I'm going to the left. Remember, these are my X values that I'm using. What I'm looking at the shaded region. That's my and those are my answers. So what does it tell me about X? Is X less than or equal to A? Again, see where it's pointing? As long as X is to my left, where it's pointing, that's the shaded region. It's equal to, because it's a solid dot on A. I can include A in my list. Now the interval notation. Interval notation always has a beginning and an end. This list of numbers here, where does it begin? Negative infinity. Positive infinity is over here. And where does it end? At A. So I use parentheses or brackets. Well, for infinity, I always use a parenthesis. Right, since A is a solid dot, I have to use a bracket there. That means I can include that number in my list. How about this one? These are my X values. So X is greater than A. Is it greater than equal to or just greater than? Strictly greater than, which because it's an open circle, I cannot use A in my list. Well, now, everybody okay? Everybody understand what I'm saying? If I can't use it or can use it in my list? Let me show you what I'm talking about. If I had a number line, tell me all the numbers I can use. 2, 3, 4. I can't use 5 because it's an open. That's what it's saying to me. If they were both open, the only numbers I can give you are only ones between, right? In other words, if it's a solid dot over it, I can include it in my list. If it's an open dot, I can't use it. I can go all the way up to it, but I can't go to that actual number. That's what I'm talking about when I'm saying open and close interval or dot. And here are my X's. So where's X related to A? X is less than A. Okay, yeah, I just noticed I missed it. So it's dramatic effect. So let's look at this one. When you do the interval notation, only look at the beginning and the end. So I begin at A and I go to positive infinity. And the bottom one here, I go at negative infinity. I start there and I go all the way to A.
You don't need parentheses.
I can't use infinity, so it's parentheses. Can I use the A's? Can I include the A's in my list? No. So those are parentheses also. If it's an open circle, it's a parenthesis. If it's a closed circle, it's a bracket. Well, easy way to memorize those. Here are the possibilities. If it's an open circle, how do you make a circle? You have two sides. That's what these are. Can they be equal? No, because you can't catch them. It's just still rounded. But this one, because there's a line down here, there's a solid line down there. Those tell you which ones you have to use. So if it has a line on the bottom, it has to have a line on the bracket also. Okay, so these four we've done so far are called the infinite, because it starts at a number and goes to infinity. Either going to be open or closed intervals. Now we're going to get finite. What does finite mean? Yeah, it's limited. It has a beginning and an end, a solid beginning and an end. These infinite ones start at a number and goes on to infinity. It never ends. These now do have a beginning and an end. So X is between those guys. Because I'm only interested in the shaded region. Those are the X's that tell me my answers. All right, let's look at this one. I begin at A and end at B. X is between there. X is between A and B. X is greater than A, but X is less than B. They're solid dots, so what does that mean? Can I include them? So I have to put a line underneath them. What this says is I begin at A. I can use A in my list, and I can continue X all the way till I get to B, and I can use that number. I'll show you what that means. Two, three, 4, 5. Listen, what's the beginning of my list? I can start, because not going to equal 2, so I can start with 2. I go all the way from 2 to 5. That's my list. I begin at 2 and I end at 5. I can use anything between there. Are they going to be brackets or parentheses? Yeah, so the interval notation always have a beginning and an end, A to B, and they're both included, they're brackets, because there's lines underneath both of them. Each of these have a beginning and an end, even these infinite ones. X is greater than or equal to A. So it begins at A and goes on to infinity. Yeah, but since it goes to infinity, I don't have to put that part in there. It just says, all I have to need to know is it's greater than A, which means it's always going to go to one direction. In this finite one, was my beginning and the end is A and B. Is A bracket or a parenthesis? B is a parenthesis. So I begin at A. My X is between A and B. My X's are between A and B. Can X equal A? It's a solid dot on A. which means yes, so it's equal to, greater than or equal to. Can it equal B? No, so X is strictly less than B. It goes infinitely close to B, but never touches it. So the interval notation of this one, you begin at A and go to B. Can you include A? No. Can you include B? Yes, because it's a solid dot. So you have your beginning and end, and X is between there. You cannot include A, but you can include B, so it's less than or equal to. Notice that this statement here, there's actually two statements. The first statement says X is greater than A. And it says X is less than or equal to B. So it's greater than A, less than or equal to B, so it only goes where those two overlap. You have beginning and an end. I can't use either of them, so they're parentheses. X is between A and B, and I can't use either of them. Because X is greater than A, but less than B. So that's when it's finite, between 2 points. Now we have infinite and bidirectional. Yes, like that. So my X's can be in either places. How would you read the first one? X is what to A? X is less than, equal to A. Or X is greater than, equal to B. In other words, you notice it said or, because if I'm thinking of a number that's in this range or this range, it could either be in here or it could be in here. Those are my correct answers. It cannot be in here. So that's why I put or there. Let's go ahead and do the set notations first, because we'll have to introduce a new symbol for the interval notation. So my X's are here. X is less than, equal to A. Or X is strictly greater than B, since it cannot equal B. And the next one? How would you put that one?
X is less than A.
Yeah, strictly, because it cannot include it. Or greater than or equal to B. Because remember, since X is bigger to the right of B, it means it's greater than. Because we're always referring to what the value of X is. In this case, X is to the left of A, then X is less than A. Here, X is to the right of B, so X is greater than B. Since they're open, they cannot be equal. Let's look at the interval notation now. It gets a little bit difficult now, because remember, interval notations are sets of numbers that you have to have a beginning and an end in each of these sets. So in this one, where does it begin? Reading left to right, where does it begin? Begins at negative infinity and goes to where? A. Now, can you include infinity? No, you can never get to infinity. So it's all infinity and negative infinity will always be a parenthesis. How about A? Is that bracket or parenthesis?
Right.
Bracket, because it's a solid dot. And then we jump over here. We begin at B and go all the way up to infinity. Again, infinities are parentheses. And this is now here's where a symbol, logic symbol comes in. Since our answer could be in either one of those directions, we're taking the union of those two sets. We have a U between there because the answer is all of these numbers and all these numbers. Those are all my possible answers. So basically, this word or is represented by the union symbol, the U. So go ahead and do the next three. Finish these next three using the appropriate bracket, parenthesis, and union symbol. Let's look at this first one. Remember, for the interval notation, we have to have a beginning and an end. So reading left to right, our values start at negative infinity and go to A. Infinities are always parentheses. What about A is going to be? A bracket. Unioned with B to infinity. It goes this side. So is B parenthesis or bracket? And infinity is always parenthesis. Reading left to right, negative infinity to A. And that's an open, so it's parenthesis. Unioned B to positive infinity. And it's solid, so it's a right. Negative infinity to A. It's open, so it's a parenthesis. Likewise, from B to infinity. Makes sense?
Yeah.
Three more to go. Let's see if you can guess these. What does this one mean? It's a point. How would you represent a point? Just A? Where's X?
Both sides?
Because there's only one dot. That's the entire interval is X equals A. Well, that's a set notation. For yes, for interval, it would be A. My entire answer is A. How about this one? It's open. What this one means now is everything both directions. To do this, we can do it two ways. What that tells me is X does not equal A. It can be anything else other than A. Or X is less than A, or X is greater than A. That means the same thing. X is less than A, or X is greater than A. It's just like X cannot equal A. It cannot equal A. And that's what that means. It could be any number you think of, just not A. I mean, you could put negative infinity to A, parenthesis, union, B to infinity. It means the same thing. How about all real numbers? whenever the answer is all real numbers, we use this symbol. Like a realtors are.
Okay.
No, we haven't done these guys yet. In other words, if it's all real numbers, it's all of these guys. So where does it start? Where does it end? Yeah, so it goes from negative infinity to positive infinity. That's all real numbers. How would you put it in set notation?
All the numbers.
The only thing you can do, because then reality, we have to put X is less than or equal to A and X is greater than equal to A. But so we're gonna do with that, we just put all real numbers. X is everything and anything. You have to be able to convert between any one of these three symbols. On your homework, you're going to say, okay, here's a question, convert it, give me the answer in set notation, in interval notation, and graph it. Let's look at an example here. Okay, we're going to be given equations the same way. Give me the answer in all three notations. So what do you think the first step's going to be? Solve for X. So we have to get rid of first. Yeah, how do you get rid of the 5? So we have 2x is less than equal to 9 minus 5 is 4. Divide by 2 both sides. X is less than equal to 2. What notation is that?
That's
Don't look at the sheet I just gave you. It might give you a hint. What is it? Set notation. Set notation is having to do with inequalities.
what?
Set notations, inequalities, interval notations, brackets, parentheses.
Okay.
It's all in the sheet I gave you. So now you have to put in the other two forms. How would you graph it? What would it look like? What would the graph look like?
Two would be.
Well, 2 would be anywhere. So is it going to be a solid or a closed, open or closed dot? Closed dot, which side gets shaded? Because X is less than or equal to 2, so it's got to go this way, which means it's going towards negative infinity. Since you have the graph, the interval notation is pretty straightforward. Where does it begin? Where does it end? Begins at negative infinity, ends at 2. This is always parenthesis. How about 2? It's a bracket since it's closed. So those are your three answers. Set notation, interval notation, and graphing. Same thing here. Give me in the other notations that are missing. 5, how would you read this?
Less than.
Now, remember, it always points to the small, so 5 is less than equal to 2 plus 3x. So your first step, subtract 2, because we have to get x by itself. 5 minus 2 is 3. Next step, divide by 3. 3 divided by 3 is 1. 1 is less than equal to x. Here's an unwritten rule. To make life easier for you, we always want x on the left-hand side. It's easier to interpret that way. So if we can rewrite it like this, but the pointy little arrow has to keep pointing to 1. So are these both the same statements? This one says 1 is less than equal to x, or x is greater than equal to 1. Which one's easier to understand? The bottom one's much easier, because now from here, I can start with the only number I have is an open or closed circle. And which direction is my line going? Yeah, because x is greater than 1. Since it's greater than, it's pointing there, it's going to infinity. That's the graph. My interval notation is going to be starting at 1, going to infinity. And since it's a solid dot, it's a bracket. Oh, okay. So those telemarketers, they call it, is your house for sale? I said, yes, for $2 billion. Don't call back unless you can pay it. Because now, if they call back, then they agree to my terms, and by law, they're supposed to pay me. So they'll never call me again. So it makes sense what we're doing here? Okay, what if I gave you this? Give me the other two notations.
What?
You have three notations. You have set, interval, and graph. What notation is this? This is a graph. So you have to now convert this into set and interval notations. What's the easiest form to put it into first? Well, the interval notations, because do we have a beginning and an end point? It begins at -8 and goes to 4. Is 8 a parenthesis or a bracket? And 4 is a, so there's that one. And remember, since the shaded region is over here, that represents my x. So my x has to be between -8 and 4. Well, you have to have it like this. Because you have a beginning and an end, I put my x between there. And it's because I know I'm going to have a finite graph. It's 8, it has no line underneath it because it's a parenthesis in this open circle. and 4 is included. Okay, do this one. So what would be the easiest one to convert to first? Interval notation. So where is this left side's going all the way to negative infinity? The right side's going positive. So what do I have? I had negative infinity to -3. Unioned with. Because these are my X values, I can choose. It has to be between negative infinity and -3. Have a beginning and an end. Beginning and an end. The only values I cannot use any of these between -3 and -1. I cannot use those. So my X here is strictly less than -3, or X is greater than -1. Because X is to the right of -1, X is to the left of -3. Kind of make more sense? I know you've all seen this before, but this is the why it is what it is.
Why did, so the graph notation you did, the first one, the -8 and 4, why did you do a union with that one?
Because we're only looking for the numbers between there. I have a beginning and an end. My X is between those two. These are infinite. It starts at -3 and goes down. So X is less than -3. X is greater than +1. So it goes from -1 to infinity. Give me this one in the other intervals.
Question about the last one.
Yes.
How do you tell the difference between finite and open and infinite and open bidirectional?
If it's bidirectional, it's by definition infinite. Because it goes both directions. It never stops. Finite means there's a beginning and an end. Like the top one.
But they're both open.
Open means I can't get to it. In other words, the answers, the list of answers for this one would be -7, -6, -5, 1, 2, 3, 4. I cannot use -8 in my final answers. I can use 4. So the list of my answers, the set of my answers would be from -7 all the way to 4, including 4. That's what those mean. Infinite simply means it goes to infinity. If it's infinite, that means it goes to infinity, either positive or negative. If it's finite, then it has solid numbers at both ends.
But if they're both open, like. Oh, yeah. So they're both open, and then they both go to infinity.
Which one?
The finite and,
Both here.
yeah, this one,
This one doesn't go, this one just goes between A and B. And it's not include, nothing else goes to infinity. It starts at A, ends at B.
okay.
these start at negative infinity, go to A, or this one goes to infinity. These are the infinite ones here. Yeah, these are the infinite ones. This one goes from negative infinity to A, B. That's an infinite series.
But how would I tell the difference on a number line if they look the same? You know what I'm saying?
You either the graph would be given to you this way, or it's given to you this way. Notice how the statements are written. This one says x is less than -3. Does it tell you where it ends? Less than -3 means it goes to the left. There is no ending, so it goes to negative infinity. It goes to infinity. And this one here, x is greater than -1, so it goes to the right. It never tells me where to stop. What this one does, if it's a finite one from end to end, yes, this one's actually two statements. X is greater than -8, and x is less than 4, less than or equal to 4. If we look at the graphs of both of those, so the -8's there, it's greater than. Now, if where these two graphs overlap, I cannot use 8. I can use 4, but it's everything else in between. It's only where they overlap I can use. But yes, this one is an and statement, but I didn't bother going through that. What you made me. No, it'll come easier to you when you start seeing how they're written. If it's given to you in set notation like this, or in interval notation like this, you know that since you see infinity, it goes on forever and ever and ever. Since there's only one number, there's no bound, it goes to infinity. If you see an x and there's numbers on both sides, it can't go into infinity. But if you see an x with only one number, that means it doesn't stop. It keeps on going that direction. Very good question. Very good question. I hope I answered it. It's just that it just takes practice until you see what it's telling you. So what would I do this next one? That's a very good question, actually. Well, have we solved it yet? We have to solve for x first. The only x we have is in the middle, isn't it? So we have to solve for x. Anything we do here, we do both of these spaces. Whatever you do to one of these parts, you have to do, this is called a tripartite. It's that they all have to be equal. If you change one, you got to change the other two. So this first one, I have to add 5, which means I have to add 5 everywhere else. Three plus 5 is 8. 5 plus 5 is 10. What's my next step? I have to get rid of the 2, so I have to divide by 2 across the board. 8 divided by 2 is 4. 10 divided by 2 is 5. So you see this list of numbers is anything between 4 and 5. Here's 4, here's 5. 4 is a solid dot. 5's open, and x is between there. That's the graph. Interval notation. I start at 4, go to 5. I have a bracket on 4 and a parenthesis at 5. So that's how you solve tripartite equations. Whatever happens in the middle, wherever the x is, you have to do it everywhere else. Let's look at one that has fractions. I know since you guys asked for it. The logic is still the same. Remember what the rule was whenever you had fractions and equal signs? No, whenever you have a fraction and equal sign, you first look for the LCD. What's the LCD in this case? What do you do with the LCD? No, multiply it to each term because it's the denominator. So if we multiply each term by the LCD, reduce it. So the threes cancel here. The threes cancel there. Now it looks a lot easier, doesn't it? In other words, whenever you have fractions, get rid of the fractions. Multiply to get rid of the parentheses. 3 times 2 is 6. And solve for x. So what do you have to get rid of first? How? Subtract 5. So 5 is bigger than 1, it's negative. 5 minus 1 is 4. 2x. 6 minus 5 is 1. Next step. Divide each term by 2. 4 divided by 2 is 2, so it's negative 2. Less than x, less than 1/2. Because the only thing you're worried about is in the middle. Whatever you do there, you gotta do to two other sides. What's the graph gonna look like? Starts at negative 2 and goes to, is it open or closed? And it goes to 1/2. Open or closed? Yeah, here are my endpoints. X is between there. That's my graph. And from the graph to the interval notation, I start with my beginning and I go with my end. And since they're both open, that means they're both parentheses. There's my interval notation. Makes sense? With practice, it'll become much easier for you. That's it. I didn't mean to make it so hard. So on this one, what do you do first?
Get rid of the 2.
How? So negative 3x. 8 minus 2 is 6. Now we have a problem. Because there's a negative in front of that 3. That negative there. If, let me show you what's going to happen. Right now it says that negative 3x is greater than 6. If we were to solve for x mathematically, we have to first add 3x to both sides. 0, 6 plus 3x. Subtract 6 from both sides. We have negative 6 is greater than 3x. Then what? Divide by 3. So -2 is greater than X, which means X is less than -2. There's a lot, yeah, but I'm showing you is why this happens. Because the answer is X is less than -2, but up until the beginning, the inequality was greater than sign. So here's the rule. Whenever, at the last step, whenever you have to change the sign of X, you have to flip the inequality. Whenever you change the sign of X, you have to flip the inequality. Whenever you change the sign of X, flip the inequality.
Oh, you're the, oh,
Because it used to be greater than, now it's less than. So I'm gonna show you my method of doing this. Remember, recap this. Remember, if we had this, how did I tell you to solve this? If you have a negative, never divide by negatives. I mean, you can, but the chances of messing up the signs is going to increase now because now you have signs like symbols like this. You're going to get that mixed up with the negative sign. So treat the signs first and then the numbers. Since this is negative, change all the signs across the equation. 3x equals -6. And then divide by 3. X equals -2. So that's what we did earlier. We solved for equations. So in our example, we had -3x is greater than 6. Notice there's no more plus or minus here. Whenever x is by itself, and so when you flip the and change the signs of the numbers, you have to flip the inequality also. You have to negate everything, change, make them opposites. So make a -3 into a +3, make greater than into a less than, make a +6 into a -6. So just change the sign across the board, negate everything, make it opposite. Because then now all you have to do is divide by 3. And there's your answer. Make sense? So that's a very important concept is if you ever change the sign of X, not if it's like this. Because you have to get rid of the 2 first. It's only when you have the X by itself. If there's no more plus or minuses here, then you change the sign across the board. Make everything opposite. And then divide. Because what would happen if you decided to divide by -3, this could easily get mixed up. You see what I'm saying? Because now is this a less than equal to, or is it less than -2? So that's why, please get away from dividing by negative numbers. Always treat the signs and the numbers separately. You'll never have the sign issues again. It even works when we have tripartite equations. No, make it. Yeah. Hmm. Make it 18. There. 10 is less than or equal to 2 minus 4x is less than 18. What's your first step? Yeah, because remember, you're only interested in what happens in this middle part. So we have to subtract 2 from everywhere. 10 minus 2, 8. 18 minus 2, 16. Okay, there's a negative in front of the x. So here, I have to change everything across the board. Change the signs of the numbers and change the directions of the inequalities. Make everything opposite. 8 used to be positive 8, now it's negative 8. Used to be less than, now it's greater than, equal to. Used to be negative, now it's positive 4x. Used to be less than, now it's greater than. All because of this negative sign here at the last step. And then from there, we divide each term by 4. Negative 2 is greater than or equal to x is greater than or equal to negative 4. Are you done? No. Why you didn't? It's backwards. On a number line, is negative 2 bigger or less than negative 4?
No.
Is it bigger or less than?
Okay.
Negative 2 is bigger. Because on a number line, we have negative 4, negative 3, negative 2. So negative 2 is to the right. So what we have to do here, we have to flip it. So this one goes there. The x is in the middle, and that one goes to the other side. This one still has to point to the negative 4. This one still has to point to the x. Now it's correct. It goes from less than to greater than. All you're really doing is taking your page and flipping it over and rewriting it. That's all you're doing there. Again, it just takes practice because graphing this would be very difficult. Because it's not, you'd have to think very hard about how to do this. My endpoints are negative 2 to negative 4, but that's backwards because it doesn't go in increasing order. It should be negative 4, negative 2, like that. Increasing order, left to right. Because your answer here would be open parenthesis there, close parenthesis there, and those are my answers. So you have to be very careful when you do these homework assignments, when you deal with tripartite, when they have negative x's. If there's a negative sign in front of the x variable, you have to be very careful because the very last step, make sure you change all the signs and directions. And for some reason, students have difficulties. How would you flip this so it's easier to write? Because basically, we always want x to be on the left-hand side. You would flip it. So you have x and negative 4 is still pointing at negative 4. So yeah, you have to make sure, yes, flipping the x and negative 4 is no problem. It's just that you have to remember that if it's pointing at negative 4, it has to keep on pointing at negative 4. So far, so good. I mean, yeah, there are a lot of things. That's why I was going to limit today's discussion to inequalities and absolute values. because this in itself is a lot of steps. I mean, an entire sheet of what you can do, 3 columns worth. Okay, let's look at absolute values. What is an absolute value? Changes the sign of the number. So the number inside the operation to make it positive. A perfect example. So it changes the sign of the number inside the operation, so it's always positive. The absolute value of 3 is 3. The absolute value of negative 5, 5. So it's a value. You cannot have an equation. You cannot have an equation inside there. If you have an equation, order of operations, you have to work that out first, because this is an absolute value, a number. So 7 minus 9, 9 is bigger, so it's negative. 9 minus 7 is 2. Absolute value of negative 2 is 2. You can only apply it to a single number. Right? How about if the negative is on the outside? What's the answer?
What? Huh?
Operations. What's the absolute value of 3 with a negative in front? There's a difference between this number because it's outside of the absolute value sites. Yes, outside the operation. Because you have this one, I included it all. So it takes this and makes it into a 3. This one, the negative stays out there. Absolute value of 3 is still 3. Yes, it is an equation. It's actually negative 1 times absolute value of 3. There's a 1 in front of everything instead of parentheses. So that's what it really means. How about that?
No, negative 5.
Positive?
Would it be negative 5?
I'm wait till you get to only one answer, because you went through both of them real quick.
Oh, that's negative 5.
Well, negative.
Order of operations. What do you have to do first? Reading left to right. Is there a special operation? Solve inside. What's the absolute value of negative 5? And the negative side. The answer is negative 5. You cannot distribute inside absolute values. Make sense? The best way I can describe it is distance. From Dallas to Fort Worth is 26 miles, right? About. From Fort Worth to Dallas is how far? 26 miles, not negative 26 miles. It's 26 miles. Distance is an absolute. You, no matter where you go, forward and backwards, it's still you're going that distance. That's what absolute values do. It doesn't, there is no direction in absolute values. So now, let's look at what it really means. Because of this, are they the same answer? Absolute value of 3 is 3. Absolute value of -3 is 3. So what that tells me is if I take the absolute value of any variable, that X can equal positive or negative. So it actually equals a positive or negative X. Whenever you drop the absolute values out of a number or a variable, it's plus or minus that number. Now, absolute value of X equals 4. What can X be in this answer? Or, so if I drop the absolute values, I get plus or minus 4. Absolute value of -4 is what? Absolute value of 4 is, so it's the same thing. Because remember, absolute value is a distance. If I give you a number 4, it's the distance from 0 to 4 is 4 units. From 0 to -4 is how far? 4 units. So it's positive and negative. It's 2 answers.
Oh, so you're not saying it's gonna be positive or negative, you're saying it's gonna be positive. It's gonna
I thought you left.
No, I have to go get you.
Okay. Yeah, so I'm saying that absolute values, whatever's inside there, it can be either positive or negative, because when you take the absolute value signs, it drops all signs. Now let's see how this works in an equation. My computer listened to the lawnmowers outside. Now it wants me to set up my professional audio settings. I'm trying to figure out how to get that out of there. So the steps of solving an absolute value equation is isolate the absolute value. So you have the absolute values equals some number. So is the absolute value by itself? Sure is. There's nothing else. Is there a coefficient? Is there a denominator? Is there anything around it? No. So that means it's isolated. It's absolute value on this side and a number. Drop the absolute value and place a plus minus in front of the number. Because remember, absolute value of X equals 4. If I drop the absolute value, X can equal positive or negative 4. So when I drop the absolute values here, the answer could be positive or negative 3. So whenever you drop absolute value signs, whatever's on the other side becomes a positive and negative. Then solve for X. Subtract. How many equations do we have now? We have 2 equations. We have 2x plus 1 equals -3. 2x plus 1 equals positive 3. solve for X. Subtract 1, it's across the board, subtract 1. Negative 4. 3 minus 1 is 2. Then divide by 2 across the board. X is negative 2. X is positive 1. These are my two answers. Because absolute values can either be positive or negative. You have two possible answers. CYA, check your answer. Our original equation was this. We had to test both answers to see if they work. So let's try the first one. Whenever I see an X, I put a negative 2 in there. So I'm gonna do this one first. 2 times negative 2 is negative 4. Negative 4 plus 1, 4 is bigger, it's a negative. 4 minus 1 is 3. Absolute value of negative 3 is 3. So that one works. So X equals negative 2 is a good answer. Let's do the same thing with X equals 1. Two times 1 plus 1 equals 3. I'm going now, anywhere I see an X, I put a 1. 2 times 1 is 2. 2 plus 1 is 3. Absolute value of 3 is 3, so it works. So X equals 1 is also a good answer. So those are my answers. So the objective here is you have to isolate the absolute value first. And then once you drop them, put a plus or minus in front of the answer and solve for X. You have two equations now. Let's look at another example. Everybody ready? Everybody still writing? Make that 2. I'll make it 2. This is what I'm going to show you what I mean about isolating the absolute value. 2 times absolute value of X plus 1, close, minus 5, all that divided by 2 equals 6. Is the absolute value by itself? No. It's got a coefficient. It's got a denominator. It's got a minus sign. It's got something added or subtracted to it. We have to get rid of those. What do you get rid of first? Denominator. Remember how to get rid of, you have an equal sign and a fraction. How do you get rid of the fractions? By what? LCD. So the LCD is what? So multiply both sides by 2. That gets rid of the fraction. So I have 2 absolute value of X plus 1 minus 5. 6 times 2 is 12. Now what do you have to get rid of? For simplicity purposes, I want to do it with fractions. Let's change this to a 4. Because I don't want to deal with fractions just yet. I'll wait till you guys are by yourself at home on a comfortable night. Then you do your homework. Fractioned out. So What do you have to get rid of first? You're sorry for, no, you have to get rid of the minus, get rid of plus minuses first. Get rid of the denominators first. Then get rid of anything added or subtracted to it.
Oh, okay.
So we add 4 to both sides. That's supposed to be a -4. It's horrible. So 2 absolute value of x plus 1 equals 16. Now
Fine, too.
divide both sides by 2. Absolute value of x plus 1 equals 8. Now, there's nothing else to get rid of except the absolute values. We can drop the absolute values, which means we got to put a plus or minus in front of the answer. Does everybody understand why we put a plus or minus in front of the answer? Exactly. If absolute value of x equals 4, that means x can be either positive or -4 inside there. It'll give me the answer of 4. Exactly. That's exactly what it means. Once you do that, then you have your 2 equations to solve. X plus 1 equals -8, and x plus 1 equals +8. Because you have to take one of each of these. Here's the minus sign, here's the plus sign. Solve for x. Subtract 1 from everybody. X is equal to negative. 8 plus 1 is 9. 8 minus 1 is 7. These are my 2 answers. And you can test them, but putting both of these inside the equation, and you'll get a solid answer in both ways. You want to try another one? Anybody still writing?
Yeah.
Anybody else, I should say. Just kidding. You still writing? And remember, everybody, now that I have a place to put the stuff, every day, I'm gonna start uploading them into your eCampus. Are you working these out?
Yeah, I was just, you know.
Okay, yeah, but it's always a good practice. Check your answers, make sure they work. Because there may be instances where it doesn't work. Case in point. I'm going to work this one out. 2 times absolute value of 2x plus 3 plus 5 equals to 3. You guys don't have to put your phones under your desk. You can put it on top of your desks. I don't mind. Let me show you what's going on. What's the first step? How? So 2 absolute value of 2x plus 3 3 minus 5 is? Since 5 is bigger, it's negative. 5 minus 3 is 2. Next step. Get rid of the coefficient. Divide both sides by 2. 2x plus 3 is equal to. Now what do you do? Wrong. You're done.
Huh? How we doing?
Can the absolute value ever equal something negative? No. Because the absolute value, the whole purpose of it is to give you a positive answer. So if you have an absolute value equals a negative number, you're done. It cannot equal, it cannot be true. That's why I want to make sure I threw that in there before you go too far. Okay. All right, so that's what we have for equal signs. Whenever you have, you will always have two values to look at whenever you deal with absolute values. That's with equal signs. Now with absolute value of inequalities, or with inequality, I should say. With inequalities, we have two possibilities. Absolute value of x is less than some number a. And then absolute value of x is greater than some number a. Let's look what this means. Because remember, from the equal signs, when we drop the absolute values, the answer has a positive and negative number, right? So if I drop the absolute value, I will have it plus or minus a. Don't write this down because I'm going to show you what this really means. Because yes, we have a positive and negative. So if x is less than a, here's a, is going to 0. X is less than a, so it's all this stuff here. On the positive side, that means also on the negative side, it has to be going towards 0. Because if x is less than a, it's going from this way. I can also look at it from the negative side. So absolute value of x is less than a. When I drop the absolute values of this equation, it becomes negative a is less than x is less than a. That's what this means. Think of it this way. If I said absolute value of x is less than 8. So here's 8. If I'm saying less than 8, what does that mean? Any numbers less than 8, right? But I'm taking the absolute values, which means I also have to look at negative 8. But remember, since I changed the signs, I had to change the inequality. So now I have to look at numbers that are greater than 8, going to 0. Because this is going from 8 down to 0. So my answer has to be between negative 8 and 8. That's what that says. So this is the rule for less than. If you have a less than, whatever the answer is, put it as plus or minus and the x in the middle. If you have a greater than, if x is greater than a, that means it's going away from 0, isn't it? if X is greater than A. Yeah, so if A is 5, give me a number greater than 5, 6, 7, 8, 9, 10, 11. Likewise, because this number here can be positive and negative, I have to go away from 0, so it's going the opposite direction. So if I have an absolute value greater than A, then it's going to be X is less than negative A, or X is greater than positive A. You have to look at both directions that the lines are going. So whenever you have a less than, that means it has to be between positive and negative that number. If it's greater than, it's going in the opposite direction. It has to be greater than A or less than negative A. In other words, it's going away from 0. So remember, the formula, the rule is this: if absolute value of X is less than A, and I drop the absolute value, it becomes negative A is less than X is less than A. So this is what you're looking at. You're looking at the inequality sign. So this, following this rule, the absolute value is isolated. Now I could drop the absolute value sign. If I do that, I have a negative 5 is less than X plus 2, which is less than 5. So now I could solve this thing. Negative 7 less than X is less than 3. And this is your answer. Let's look at this one. Your first step is always to do what?
Gotta get rid of one.
Yeah, you have to isolate the absolute values. So are there any denominators? No. So that's okay. Any plus or minus? Yes, we have to get rid of the plus or minuses next. Subtract by 4. Eight minus 4 is 4. Is the absolute value isolated? So what do we have to do? Divide both sides by 2 to get rid of its coefficient. So we have absolute value of 3x minus 1 is less than 2. Since it's a less than equation, I gotta take the positive and negative of this. So it's negative 2 is less than 3x minus 1 is less than 2.
So that's your final answer?
No, my final answer has X by itself. This is my next step. Once I drop the absolute value sign, I convert it this way because it has to be a positive and negative 2. Since it's less than 2, that means it has to be greater than negative 2. So what do I do next?
Honestly, you do, I mean, add it.
Add one.
Oh,
Add one to all three terms. But yes, you're right. It had to do with the one. Negative 2 plus 1 is negative 1. 2 plus 1 is 3. Divide everybody by 3. Negative 1/3 is less than x is less than 1. That is your final answer. Again, it's just to remembering, if you have your original equation, if it's a less than symbol, then you know you have to take the answer and put it a positive and negative, put it on both sides. Everybody see why that's so? If I said absolute value of x is less than 2, that means I can go from 0 to 2. But it's absolute value. What about the negative 2? Since this one's going to 0, this side has to go to 0. So when I drop the absolute value for a less than symbol, wherever the answer is, goes on both sides of whatever's inside the absolute values. That's all there is to it. Whatever's inside here will go there. If it's greater than, that means I'm going to infinity. I'm going away from 0, which means I got to do the same thing here. I have to go away from 0 to negative infinity. So if the symbol, original symbol is greater than, x is less than negative 2, or x is greater than 2. X is greater than 2. That has to stay there. When we take the negative of it, x is less than negative 2. Has to go greater than positive 2, less than negative 2. How about that? Is the absolute value isolated? Is there a coefficient? Is there a plus or minus? Is there a division? No. So it's isolated. There's nothing else around it. Now I can drop the absolute value. Because it's greater than, I know I have to use this formula. X is less than negative a, or x is greater than a.
What is it?
Because it's a greater than symbol, the formula says when you drop the absolute values, x has to be less than the negative of the answer, or x has to be greater than the answer. So 3x plus 2 is less than negative 4, or 3x plus 2 is greater than 4. That's what it means. Whatever's inside the absolute value sign is going to be less than that number or greater than that number. You guys are looking like it's a unicorn. Am I confusing you? Or is it not making sense yet?
It's
One person. What do you do next?
the answer.
Solve it, right?
Do,
Subtract 2 across the board. -4 minus 2 is -6. 4 minus 2 is 2. Then divide by 3. X is less than -2. Or X is greater than 2/3. Those are my answers. If I gave you these equations, could you solve them? If I gave you both of these, could you solve them? Let's try it. Let me give you one. Let's see if you can solve it. Because if you can do that part, then we can just work on converting these from this equation to that. Because this is all what we've been doing all along, order of operations. It's just that getting from there to there. Once we get there, it's a piece of cake. Okay, solve those. Two x minus 5 is less than -3, or 2x minus 5 is greater than 3. What do you do first?
Add the bottom.
Yeah, you have to add across the board to each term. We have 2x is less than, they're both negative, 5 plus 3 is 8. 2x, 5 plus 3,
Wait, why don't you do this subtract?
oh, that's a good point. I got carried away with the signs. So it should be -2. Or +2, +2. Good catch. Then you divide by 2, each term. So x is less than 1, or x is greater than 4. That's just mechanics. So the problem is, going from here. Because if I give you this part, you can work them out. This is only one step from this. Absolute value of x is greater than a. So x will be less than -a, x will be greater than a. This number here is our x. This number here is our a in this equation. So whatever's inside the absolute values goes down first. On the negative side, it's less than. Has to be 3. So whatever this is, 3. And it's greater than on the positive side. Whatever this is, it goes there. That's your A. Now, can you solve that? So the hardest part is going from the inequality, absolute values, to the two separate equations. Once you get it isolated into this form, whatever's inside the absolute values, write down just as they are. One side will be less than, one side's going to be greater than. The less than will have a negative sign in front of the number. The greater than will be just the number itself. That's all there is in the conversion. Set this equation up. Get rid of the absolute value sign. What's my first step? Get rid of the 2, correct. Because we have to have the absolute value sign by itself. 6 divided by 2 is 3. Since it's greater than, I'll have whatever's inside here less than, whatever's inside here greater than. The greater than is already that value. The opposite direction, I have to change the sign. And that's all there is to it. And then work it out. And that's just mechanics from there on out. Okay? Any questions so far? Yeah, now is where you have to practice these. Because yeah, it's easy when I do it because I'm asking you the right questions. You have to think about when you're doing it yourself. What do you do next? What do I have? What do I do next? Those are the most important ones. So that's why I'm going to stop here for today. We finished chapter 1. This is it.
You're gonna solve them?
You can do that. That's why I asked you earlier. Can you solve them? What do you do next? Subtract what? Subtract 1 across the board. So we have 5x is less than -4. 5x is greater than 2. Divide by 5 across the board. So we have one side, we have x is less than -4/5. That's this side. Or x is greater than 2/5. There's the answers. Am I gonna solve it? No. Everybody okay with that?